Okay, so lesson 8. We're going to use our knowledge of transformations and our knowledge of absolute values and our knowledge of radicals and our knowledge of rational expressions to write domain and range without your graphing calculators. Okay, without you, and we're going to do it in interval notation. Yeah. So domain is a set of all x and range is a set of all y. We're good with that, right? Yeah. Okay. So with this guy, one way to find domain and range is you can actually graph it, right? We could graph it. That's one way. So if we take this guy, what transformations are happening? So y goes to negative y. Greg, what's that? Reflection in x-axis. Okay. X goes to x plus 2 means horizontal to left. And then y goes to what? Y plus 6, so 6 vertical translation, 6 down. Okay, so let's do that. So we know what absolute value looks like, right? Absolute value looks like a V. We're just doing absolute value of x. There's no square in there. Okay, so we're just going to put in our key point. So if we're going to go 2 left and 6 down, it used to open up, but we're reflecting in the x. So here's our point, oopsie, kind of right here, negative 2 and negative 6. And then there's our graph. Right, so if we do a rough sketch, then writing the domain and range can be really easy. So now, what's my domain of this function? Real, so how do we write that now? Oopsie. No, instead, negative infinity to infinity. I know, infinity is actually kind of hard to draw. They really are. Look at me. I've had years of practice, and they are still horrible. Some people just do 2 circles. But I don't like 2 circles. Okay, range would now be from negative infinity to negative 6 close bracket. Right? I know, it's such a habit to do x is less than negative 6. Okay? All right, so graphing is a great way. Moving on. Finding domain and range algebraically. So we have to consider a variety of relations. So even powers are always opening up or they're opening down, no matter what. Right? So if you have a 4th root, it could look something like this. Right? A 6. I mean, okay, that's a little bit exaggerated, but they're either going to be opening up or opening down. So they're going to have a max or they're going to have a min. Odd, right? If it's odd powers, then we have starting in, usually it's going from the, how do I say this? This would be 3rd to 1, right? Or 2 to 4. 2 to 4. We'll look at even roots. We'll look at absolute values, rational expressions, and functions with constraints. So let's talk about even powers. So isolate the even power. Even powers result in positive values or 0. The left-hand side of the equation must be greater than or equal to 0, then so does the right-hand side. So let me explain what I'm saying. So in this problem, what we want to do is isolate the even power. So who's our even power? Y squared. So let's get y squared by itself. So I'll start by subtracting x, and then divide by negative 1. So x minus 8. So what do we know about y squared? We're just finding the domain of this one. Yeah. So, well, whenever you square something, what do we know about that? It'll always be positive whenever we square a number. So since this left-hand side is always going to be greater than or equal to 0, and these are equal to each other, then we can say the right-hand side is going to be greater than or equal to 0. So x minus 8 is greater than or equal to 0. So x is greater than or equal to 8. Cool. Okay, so writing that in interval notation. 8 sideways 8. Oh, that was a good one. I brought out the big guns today. Okay, example 2. Do you want to, well, we have to do this both twice. So we want to find the domain and range. We're going to isolate the even power. So we're going to do both this time. So if we start with finding the domain, then we want to isolate the y. Okay, so if we're looking for the domain, I'm going to start by isolating the y squared. Uh-oh. There we go. So let's isolate the y squared. We can do that, right? Yeah. Subtract. Oh, yeah. Thanks for being positive. You're just trying to get in the video, aren't you? And yeah, so then therefore y squared equals 4x squared plus 16. Okay, so here, what can we say about this left-hand side? It'll always be greater than or equal to 0. Positive, therefore the right-hand side greater than 0. So we're going to take that inequality. 4x squared plus 16 has to be greater than or equal to 0. Okay, let's solve this. So start by, let's get x squared by itself. Subtract 16. Then divide by 4. Okay, what will this be? X squared is going to be a positive. This is a negative. And what do we know are positives compared to negatives? Is that always true? Yeah, positive is always greater than negative. So therefore, our domain is all real numbers. Guys, are you with me, or are you just off in who knows what land? Can you stay here? Okay. Well, it's all real numbers, because no matter what we put in for x, it'll always be greater than negative 4. So anything can be x.
Yeah, but you can't, if you just found like x, you can't get the square root.
Right. We're not trying to, yeah, in this case. There's no solution for one particular x. But no matter what, a positive is greater than a negative. That's always true. So we can put any number in for x. So just from... Okay, so guys, can I just teach this lesson? And then if you have questions really pertaining to this, because I don't know what you're talking about. Okay, so range. So range, we're going to isolate the y squared. Or the, sorry, range, isolate x squared. Range is for y, so isolate the x squared. So adding the y squared to their side. Okay, and then divide both sides by 4. Okay, so we know what about the left-hand side? Yeah, it's greater than or equal to 0. So then therefore this is greater than or equal to 0. I don't know. Thank you. I don't like something. So 1/4 y squared minus 4 is greater than or equal to 0. Okay. Then add 4. Greater than or equal to 4. Then times by 4. Then we can square root it, but you have to do, so great or, right? Remember great or? Great or, so the union of the two. And so if I square root both, I'm getting ahead of myself. Yeah, well, I was thinking square root of 16. Sorry. So I don't know, you can do an interval test here. What are our critical values? -4 and 4, including, because of the equal to symbol. So let's just do a test. -5 squared, would that be greater than, yeah, so that would be here. How about 0 squared? Would that work? No? And then, yeah, that would work. So it would be from -infinity to -4, closed, union, 4 to infinity. And there you go. Okay, roots. How do we deal with radicals? Well, we're going to use the concept that you can't take the square root of a negative. And so that's going to help us find our domain and our range. So moving on, we got this down? Life is good. I don't know if we're going to get through all this today. Okay, the key is to isolate the radical. Whoa, that was loud. So let's first start with that, and then we'll go through each step. So get the radical by itself. First step, subtract 2x, then divide by -1. So it becomes root 3y plus 1 equals 2x minus 10. Okay, so there's the radicand. Guys, the radicand and then the radical. Okay, so the radicand, what do we know about the inside of a radical? Has to be greater than or equal to 0, because you can't take the square root of a negative. So the radicand has to be greater than or equal to 0. So 3y plus 1 has to be greater than or equal to 0. Can't take the square root of a negative. So -1 over 3. Okay. So if I don't know. Sorry. I'm sorry. Okay, so that would be what is in for y, so our range, that's our range in this case because it's y. So it's from -1/3 to infinity. Now, this here, root, because you can't take the square root of a negative, even if you take the square root of a positive, what's the outcome going to be? A positive. Awesome. So this side is going to be greater than or equal to 0. Okay, so because this output, the radical, guys, okay, so because when we take the square root of a number, it's always going to come out positive. So therefore, this side is also greater than or equal to 0. So 2x minus 10. Now, is this going to give us our domain or our range in this case? Domain, because we have an x in here. So we add 10 divided by 2. X is greater than or equal to 5. So it'll be from 5 to infinity for our domain. That was a funny looking bracket. Do you want to try the next one on your own? Yeah. Okay, try example 2. So you should have isolated the radical first. Okay, so the inside, 3 minus 2x has to be greater than or equal to 0. So that would be 3 over 2 is greater than x. So therefore, x is less than or equal to 3 over 2. So your domain would be from -infinity to 3 over 2. Okay, so then again, this has to be greater than or equal to 0. Half y plus 5 over 4 is greater than or equal to 0. Now solving this, subtract 5 over 4 times by 2, and we get y is greater than or equal to 5 over 2. So 5 over 2 to infinity. That's our range. Oh, yeah. Thank you. So helpful having you guys around. Maybe. No, I subtracted 5 over 4. No, but I added 2x over here and then divided by positive 2. So this, right? If you have x on this side, then it would flip. Yeah. Okay, moving on. Absolute values. They're so much fun. Okay, so the thing about absolute values is anything can go on the inside. I'm going to highlight that. So important. Yeah. Absolute value can be all real numbers. Inside the absolute value is all real numbers. Guys. Okay, honestly, do we need a sitting plan? What's going on in the recording? So years from now, there will be people listening. It's like, oh, they were talkative. Okay, so inside the absolute value, right? You can put in a negative, you can put in a positive. What's going to happen though when it comes out of the absolute value? It's going to be positive. So we're going to isolate the absolute value, and so we know inside could be anything, but outside has to be positive or 0, greater than or equal to 0. So how do we deal with it? We isolate the absolute value. So in this case, subtract 9. 4y minus 25 equals Thank you. What's happening to me? Okay. So that can anything go in for x? Yes. So therefore, what can we say? So anything can go inside. So x is the reals. So we'd say for the domain, beautiful. Negative infinity to infinity. However, the absolute value is going to make what happened to this number? Has to be positive or 0. So this side is greater than or equal to 0. So 4y minus 24 is greater than or equal to 0. Add 24, divide by 4, y is greater than or equal to 6. So our range, beautiful. Okay, there you go. So that's how we deal with absolutes. Can you try the next one on your own? So isolate the absolute values, your first step. Try example 2. Okay, try example 2. Start it up on the board then while you keep working. Okay, so you should have had for your range, anything can go inside for y. So y is there, but this has to be greater than or equal to 0. 7 over 2 plus 5 over 2, x is greater than or equal to 0. So I'll add 7 over 2 over, times by 2, I guess, then divide by 5. So 7 over 5. So it should be your domain. You should have had from 7 over 5 square bracket to infinity. Did that go okay? Yep. And great? Sweet. Okay, rational expressions. Well, we might only get up to like part B's first technically for tomorrow. So we'll see how it goes and how your brains are doing. Okay, so rational expressions. How do we deal with rational expressions? Well, isolate the rational expression. There's like a theme here. Yeah, isolating, a lot of isolating. What's a rational expression? What's the root word? Ratio? What's a ratio? Fraction, yeah. So a fraction, an expression, no equal signs, right, has variables. So a fraction has a fraction. So we're going to isolate the rational expression. So in this case, how do I isolate it? Add 11, so we get 4x plus 12. Yay. No need to right now for domain and range. Okay, so there's just restrictions, right? What are the restrictions on this? Does it have to be just greater? Y can't be 5. So with rational expressions, the denominator can't be equal to 0. Can it be a positive or negative value? Yeah, it just can't be equal to 0. So here, the denominator can't be equal to 0. So that's going to give you one of them. The other thing, is there a number you can put in here so that 8 over something equals 0? 8 divided by something equals 0. Is that possible? No. So then this side also can't be equal to 0. Because there's no number you can put in here that for y that actually make 8 divided by something equal to 0. So, yeah, so then, so we have two of them. So the range, y can't be equal to what? 5, right? Add 5. So that, how do we write that then? If it just can't be equal to 5? Negative infinity, 5, round bracket, beautiful. Okay, so then we also have that this side can't be equal to 0. So 4x plus 12, this is where we're getting our, in this case, vertical and horizontal asymptotes. So what can x be? Negative 3. Minus 12 divided by 4. So we'd write for our domain, negative infinity to negative 3, round bracket, union negative 3 to infinity. Yeah, so do you want to try the next one?
Sure.
Okay, try the next guy. Okay, so did you get the same thing? Woohoo! Alright, so there's her domain and our range. Turn the page. Okay, so the last thing for this portion of the lesson is functions with constraints. So there's two ways to solve this. One is to isolate the variable with the constraint. I'll show you. So it has its own set, like defined domain and range, or domain. Okay, so this one says find the domain if y is between -1, so y is greater than or equal to -1, or less than 4. There's two ways to solve for this. It's really easy. The first way is to just sub in your given values. So in this case, my given range values, and solve for the x. Okay, there's two ways. I'll show you both. The other way is we rearrange this equation for y equals. I'm going to replace y inside there. So I'll show you both. I don't know. The reason why I'm showing you both is they in calculus do things like this. So So you're familiar with what it looks like. So getting y by itself here, we subtract the 4x and then divide by -3. Okay? And so I'm going to replace the y in my constraint with what y equals. So what's y equal to? What? 4/3 x minus 7/3. And that's our y, and that has to be greater than or equal to -1 and less than 4. That's our y value. So I just replaced, right, the y with what y equals. And then we can break it up into two inequalities. So our one inequality is -1. It's like grouping. I don't know. Kind of. I don't know what you mean. But yeah, like it applies to this one, right? And then this here. And do two separate. Because y has to be less than 4 and it has to be greater than or equal to -1. So add 7/3. What does that give us? So that's -3/3 plus 7/3, -4/3. So we got -1. So divide by 4/3, so -1. So x is greater than or equal to -1. Did you get the same? No? Yeah? Yeah? Thank you. So it's a positive one. Cake. I need to bring cake. Okay, so then we bring up the next one. So 4/3 x minus 7/3 has to be less than 4. So add 7/3. 12/3 plus 7/3 is 19/3, right? We can basically get rid of the 3's and then divide by 4. Okay, so it's between, so it's greater than 1 and less than 19/4. So we would write that as greater than 1 and less than 19. So from -1, positive 1 actually, to 19/4. That would be our domain, right, for x. The other way to solve this is simply just plug these in for your y, solve for the x values. So when y is -1, what's x? Way easier, yeah. Because often they show this in calculus. So you need to know how to deal. No. Same thing. Right? So we plug in x. So what does x equal? So I have 7. 4x minus 3 times -1 has to equal 7. So then that would be 4x plus 3 minus 3 is 4. Divide by 4 is 1. So this guy is now going to become 1. And then we just figure, okay, when y is 4, what's x? Yeah? Thank you. On the second one? Yeah. Okay, so then we plug in y is 4. So 4 times x minus 3 times 4 equals 7. So add 12, divide by 4. And you plug it in there. Okay? It's not that hard. Like it's basically you're given a function, I tell you the y values, what would be the x values? It's between. Okay, so what are you guys thinking? Keep going, or are you thinking that do homework and your unit exam will be next Friday? Okay, let's do a vote.
Why can't we hypothetically finish the lesson tomorrow, practice exam on Tuesday, and then the exam on Wednesday?
Because you guys told me that you have a math exam on the Wednesday. That's why. Well, I was trying to be nice.
That is nice.
Okay, put your hand up if you'd like me to keep going. Put your hand up if you'd like me to keep going today. Finish lesson 8 right now. Okay. But then the test will be on Tuesday. Okay. Okay, guys. This is it. I will end here. So open up your homework. You prefer it on Wednesday? Okay, we can talk about that too. Hey guys, who here, we need to take another vote. We can either start 2 lessons in limits, will actually be like 3, and then practice exam, then unit exam next week. Or we can have your exam on the Wednesday, which would be, so you don't have to get limits in your head. But that means you'll have an exam the same day as your Math 30.
What is limits? How much do limits relate to this stuff?
It's,
Could we use limits in this?
no, you can't use limits in this, but use this stuff in limits.
So let's do Friday.
Okay, Friday, hands up for Friday.
Thursday.
Hands up for Wednesday.
Why is Thursday so short?
Okay, well, that settles that. So it's Friday. Okay, so your homework. Listen up. When Friday, the homework. So lesson 8. The first part, there's 2 parts to lesson 8. So lesson 8A, today's stuff, is just the minimum ACEGI for number 1. That's it. Number 1, ACEGI. Okay?
Or just down that one side right there.
Yeah, just down that one side. If you would like to try the other ones, you're more than welcome to.